In lesson 1.7, we're going to be learning how to complete the square for a quadratic trinomial expression, and you'll be able to use completing the square to solve a quadratic equation. So to begin with, let's look at solving the quadratic equation using square roots. So this is just a reminder of how things can go from what we've learned before. So if we're looking at this equation right here, and I want to take the square root of both sides, the first thing I want to do is recognize that 25 is a perfect square. So I can take the square root of the right side as it is. However, the left side is still in a trinomial formation, so I just need to factor that, and I'm going to factor that so that it's x minus 4 times x minus 4. Alright, that's negative 4 times negative 4 is positive 16, but those two numbers add to negative 8. So I can rewrite this so that it is x minus 4 squared equals 25. That's going to make it easier for me to take the square root of both sides. So I'm going to go ahead and take the square root of both sides. On the left, I'm going to end up with x minus 4, and on the right, I'm going to end up with plus or minus 5. So when I add 4 to both sides, I'm going to end up with two answers. X is going to equal 5 plus 4, which is 9, or x will equal negative 5 plus 4, which is negative 1. So my final answer, x is equal to 9, and x is equal to negative 1. Now I could have done this another way, but because it told me in the directions to use square roots, I had to go about it the way that I've shown you here. The next thing you see on your note sheet is some information about completing the square. So this is completely new. We're going to go ahead and read through it, and then we're going to do some examples that show you how to use it. So as you can see in the example that I just did, the trinomial x squared minus 8x plus 16 is called a perfect square trinomial because we were able to write the factors as squares of each other. So x minus 4 times x minus 4, we rewrote it so that it was just x minus 4 squared. So this is why we call the number 49 a perfect square, because it can be written as two identical factors, 7 times 7, or you can write that as 7 to the second power, 7 squared. But what happens if a trinomial isn't a perfect square, such as this one right here? To overcome this problem, we can add a certain number to the expression and make it a perfect square, and this is what we call completing the square. So we're going to learn how to make a expression that is not a perfect square into one that is, and it's useful because it can be used to solve any quadratic equation if it's in this form, the standard form, and that can't be said for the square root method that we've been practicing in class already. So let's go ahead and take a look at example number 2, and it's just going to walk us through the process of completing the square. So the first thing we have to do is take a look at what we have. B is 16, A is 1, and C is the number that we're going to figure out because we were going to complete the square. So the first step to completing the square is finding half of B. Well, 16 is what we have for B, so half of B is 16 divided by 2, and now that is just going to be 8. Square that answer from step 1, so we're going to square the number 8. And it says use your answer from step 2 as the C value in the trinomial. So now I can rewrite my trinomial with the C value that I came up with by taking half of the B value and squaring it. And now I have my C value. It says write the perfect square trinomial as a binomial squared. Okay, so that means that we're going to take x minus c squared or x plus c squared, and what I like to remember is whatever half of b was is the number that goes into that binomial. So whatever that number is, that's the number I'm going to use in my binomial. So this is x plus 8 squared. So remember, 8, when you multiply 8 times 8, you get 64, but 8 plus 8 is 16. So you might have to look at it a little bit more carefully if you have a subtraction symbol, you know, in either of these places here. So it might end up being a minus sign in your binomial. So that's just something you have to pay attention to and make sure you do it the right way. So let's take a look at the next example. Example number 3. We have 3 problems here. Let's take a look at A first. It says complete the square for each trinomial. So we're going to use those steps that we just did, and we're going to practice doing this. So we're going to take half of 14. 1/2 of 14 equals 7. And then we square 7, and that's 49. And so therefore we have x squared plus 14x plus 49. And if I wanted to factor this, I could write it as x plus 7. Remember, 7 is the number that I got when I took half of b, and that's the number that I put in there. All right, so I did complete the square. That's this step here, and then I factored it. Now I would like you to try b, so b is going to be on your own. And C is a little bit challenging because we have a negative sign right here, and we also have an odd number as B. So I'm just going to walk through that with you. What is half of 9? Well, half of 9 is going to give us a decimal, and that generally doesn't work very well, so we're just going to leave it as 9 divided by 2 because that is half of 9. 9 divided by 2 is 4.5, so that is what half of 9 is, but let's leave it in this form. That's going to be easier for us to write in our expression. So what is it when we square 9 halves? Well, 9 times 9 is 81, and 2 times 2 is 4. So this is my C value, and I can rewrite this x squared minus 9x plus 81 over 4. So this is what I get when I complete the square. I know it looks a little odd, but that's how you're going to have to do that when you have an odd number as a b value. And let's remember that when we write it as a factor, when we factor this trinomial, I'm still going to use that 9 over 2, and that's going to look like this. Okay, so there's the factored version, and we also have our version that we completed the square. Please do problem B on your own, and we're going to go ahead and move down to the next example. Solve a quadratic equation by completing the square. Now in the previous example it was just an expression that we were completing, but this you can see has an equal sign, so that's how we know it's an equation, and we have to do an extra step to get our problem so that we can actually know what x is equal to. So the first step says get one side of the equation in the form ax squared plus bx, which means that we don't want the constant 6 on the left side. So to get rid of that 6, I need to subtract 6 from both sides. So minus 6 from both sides. Okay, and so to get that, I'm going to have x squared minus 12x equals negative 4. Okay, so when I subtract 6 from 2, I get negative 4. It says complete the square for the side with the ax squared plus bx, and half of 12 is 6, so 1/2 of 12 is 6, and when we square 6, we get 36. So now I have x squared minus 12x plus 36. And it says in step 3 to add this, which we've already gotten. Remember we took and squared, that's the number here, 36, to both sides of the equation. Well, I added it to the left side here. So we just need to remember to add that to both sides, because if you add something to the left, you have to add something to the right. So if we're going to take and add that, Okay, I can finish up and combine that into just a positive 32 on the right. And then it says to write the left side as a binomial squared. Remember, the number 6 was half of 12. That's what's going to go inside our binomial on the left. Okay, but we have to determine, is that going to be a plus sign or a minus sign? Well, right here we have a minus, so that means that the numbers have to add to negative 12, but multiply to positive 36. So that indicates that we need to have that subtraction sign there. And when we square a binomial, that's what it looks like. Now, so this is basically this in factored form. Okay, whenever we find half of b, that's what's going to go inside our parentheses for the binomial. And it does say to finish solving the equation by using square roots. So we want to take our x minus 6 squared, and remember that's equal to 32 over on the right. And it says write your answers in terms of I if you have to square root a negative number. Well, we don't have that situation for this one, but we will have that in another example. So let's take a look at if we take the square root of the left and take the square root of the right. On the left, I'm just going to have x minus 6. But on the right, I have the square root of 16 times the square root of 2, and that's just because I factored 32. And I like to do that using perfect squares like 16, because now this becomes plus or minus 4. Remember, when we take the square root of anything, we have a plus or a minus there. So to solve for this, I'm going to go ahead and add 6 to both sides. Okay, so to clean this up a little bit, this is gone. I just have my x over here. And to clean up the right side, I'm going to have 6 and plus or minus 4 root 2. I wasn't able to do anything with the root 2, and the 4 came from the square root of 16. So there's our final answer. Remember, a number that doesn't have a root with it cannot be added to anything or subtracted from anything. So this plus 6 came from, remember, when we were trying to get rid of the negative 6 here, so that's why I still have that right there. If you're having trouble with finding these answers, please make sure you ask for more explanation in class. All right, let's go ahead and take a look at example number 5, because we're going to be completing the square with this one. And I'm going to have you do example number 6 on your own. So example number 5 says solve this equation by completing the square. So remember, the first thing we want to do is take a look at our b value, take half of it. 1/2 of 4 is 2, and when we square 2, we get 4, and that means we have to add 4 to both sides once I get rid of that 7. Remember, I have to get my 7 over here. So I'm going to subtract 7 from both sides, first step. Alright, and then I'm going to take my 4 and add it to both sides. That's because I took half of this 4 here and then squared that number that I got. So I'm going to end up with x squared plus 4x plus 4. I'm going to add that also to the right side, plus 4. And that just cleans up as a negative 3. So my equation that I'm dealing with here is going to be x squared plus 4x plus 4 equals negative 3. Alright, and then I'm going to write the left side as a square. So a binomial squared. I'm going to go over here because I'm running out of room. So x plus 2 squared, that's the factored form of this side of the equation, equals negative 3. Now I'm going to have to take the square root of both sides. So I'm going to take the square root of this and the square root of this. Now remember, just a second ago we said that if we have to take the square root of a negative number, we need to write our answer in terms of I. Alright, so I'm going to move down here so I can finish this up. On the left side, I'm going to end up with just x plus 2. And on the right side, I'm going to end up with I square root of 3. And of course this is plus or minus. And then I also have to subtract 2 from both sides because I'm looking for the answer for x. So that's gone. I'm left with just the x over here on the left. And that means that I have negative 2, remember this negative 2 doesn't have an I or a square root with it, plus or minus I root 3. Okay, so if that seems like a lot right there at the end, we'll do some more practice in class. I would like you to complete example 6 on your own, and then you also had, I think, problem B up at the top to complete, so make sure you do this one as well. And then we will do some practice in class.